and it works by that software making models of the future of some real world data stream, some price or some metric of the weather, some government statistic. Each one of our neurons, each one of our nodes looks out at the real world and makes predictions of it and broadcasts that to the rest of the network. So that's basically the idea.
Sort of text classification models, has access to LLMs. Um, you said it builds and trains its own model. How does that work? Does it provide the context of other neurons into that specific neuron, or like how does the training process operate?
And the history of the predictions. And you can see, now this is the average, right? Because every data stream, of which this is just one, has multiple predictors on it. So this is the average of all their predictions over time.
Uh huh. Hi everyone, and welcome to another episode of What About AI Agents. Today we have with us Jordan Miller, who is the creator of the Satori Network, which is basically a brain-inspired decentralized AI. And I'll let him explain what that means. But sounds really interesting, and I know he's been a lead developer at Moontree, has an expert in the blockchain, those tokens. Let's hear it from Jordan.
Hi, how are you?
Uh,
So, Satori, the project that I founded, is a open source, open distributed network of AI bots that are all predicting the future.
mm,
So they're not agents yet themselves, but they are providing data that agents could use to make decisions and to act on your behalf.
mm,
Yeah. It works through, we have a piece of software anybody can download, and it works by that software making models of the future of some real world data stream, some price or some metric of the weather, some government statistic. Each one of our neurons, each one of our nodes looks out at the real world and makes predictions of it and broadcasts that to the rest of the network. So that's basically the idea behind the Satori network.
So is this going to, like you said, right now they're just bots, but it could be decentralized agents that could potentially be all like neurons, I guess. So you're trying to model the neuron through blockchain, is that it?
Yeah, I mean, there's a piece of software that has a automated AI engine. It's an AI where you can download it and run it on your machine. We call that piece of software a neuron, because, like real neurons, they connect out to each other and they send each other signals. You know, um, the neurons in your head, basically, when they fire, they're making a prediction. They're saying, all of the neurons that I connect to, a portion of them, are going to fire next, because that's actually what they're trying to cause to happen. They're saying, I'm trying to get you guys to fire. So they're making an implicit prediction that the ones they're connected to will fire next. And so, even down at the neuron level of our brain, we're always making predictions of the future. That's kind of why we chose to call the software a neuron, because out in the real world, we now have this global network of computers that are sending signals to each other and predicting the future.
Mm. So can you give me like a practical use case or an example of where this could be applied?
Oh, sure. Sure. We're trying to build a world model so that we can kind of understand the world, understand the largest aspects of the world and how they relate to each other, how government behavior modifies things. And once you have that world model, you can then use it to give you insight on any particular thing that you want to predict into the future. So if you have a company or if you're in an industry and you want to be able to predict that industry into the future and see where it's going to go, It sits on the foundation of a world model, an understanding of the world at large. And then once you understand the world and maybe that particular industry, you can start ingesting data from specific companies and understanding how that data will mutate over time because you have a broader context to place that data in and to extrapolate it into the future. So, and it just keeps going from there. You can get more fine tuned and more specific all the way down.
Mm, right. So this is fairly high level. So I understand there are predictors. Okay.
Yeah,
So what do these predictors actually predict? So guide me through, like, let's say, like, how would this, like, so you're saying it can be used for prediction or for analysis. So this could be, for example, used for data analysis, for example, at a company, right? So how would that be applicable? Like, how do we apply this?
sure. Yeah, it can. My background is in business intelligence,
Mm-hmm.
and I discovered that a lot of the questions people would ask executives and whoever, usually they would ask a question and they didn't really know exactly what they wanted to know. Because then when you'd give them the answer, then they'd come back with another question that was related, but really closer to what they really wanted to know. And I discovered that over time, really what the thing that would give them the biggest bang for their buck, if they could just ask one question and get kind of as much information as we could offer as a business intelligence group, they would just ask the question, what's the future of this particular data? I look at sales each month, sales numbers, or I look at XYZ. I just want to know the future of it so that I can then make the right decision on how to, change my behavior or reinforce certain things that I'm doing. So I began to see future prediction as a generalized form of business intelligence or just intelligence at large. And so, therefore, I don't know, does that kind of answer your question?
Yeah, it's starting to make sense, right? So you're trying to mimic an analyst's mind with these neurons. I'm just trying to connect it to the, like, to the practical use cases, so I can understand that we can take this thing, we can mine it, and then it will produce these neurons. And then, like in the crypto, there is always the question of utility, right?
Yes.
So how do we create utility for this? So let's say there is a developer who is listening to us. He
Sure.
thinks that's a cool concept. Well, I want to make a utility. How do I utilize this in a practical way so I can make the coin circulate? So to
Good question. So we have been up and running. We launched like 7 months ago. So we've
speak.
been up and running, and which means our product is very prototypical. Our network is fledgling, so we're
Mhm.
very young,
Yeah,
and we haven't really been focused on getting the right data streams. We've been focused on building the infrastructure and testing the infrastructure, making sure stuff works.
right.
So um, we've just kind of let any data stream that people want to put up be on the network. And so the first things that got put up on the network by the node operators are data streams that were low hanging fruit, easy stuff to grab, which was crypto prices,
Okay.
um, the weather, weather
Mhm.
metrics, API, any free API, that kind of stuff. And so we actually have a lot of crypto prices predictions happening every day. And even though we want to get to this point where we're building a world model, we have some of those data streams on, and we're going to have more. But even at this stage where we've just been predicting crypto prices,
Mhm.
there are members of the community that have started to use those crypto prices to trade the markets. And I was very surprised that they were being profitable already because I thought prices is one of the most difficult things to predict. It's one of the most chaotic. It has the highest entropy. So it should be like not a good use case right now.
Huh.
But I was surprised. I mean, they found a way to use it, apparently. So that's one use case we've already seen start to happen. But there's all kinds of use cases. Everybody wants to know the future of something, and it's whatever they pay attention to. So if
Hmm.
you're the CEO of a company, you want to be able to forecast out all the things that are going to change in your environment, and that's technological. What regulations are going to happen, how is the economy going to change, what are the demographic shifts. You want to know all of it because you need to kind of forecast how your company should maneuver in the new environment. And so I kind of feel like, no, let's take maybe an example that's more consumer, instead of like business to business or something.
Hmm.
Let's say I have a Fitbit or some Apple Watch or something, and so it's tracking my heart rate and like 7 biometrics or something. Um, I might want to pass all of those to the Satori Network
Uh-huh.
to get a prediction of the future of all of them in real time, all the time. A subscription to the future. And therefore, if I see, if I start getting a prediction that's like, oh, your heart rate's not looking so good over the next 30 days or something, that could be useful information for me to change my behavior or, do something. So, yeah, if we can see the future before it happens, it's just generally useful as long as it's the future we care about, something that's relevant to us.
Right. So essentially, these neurons. So are they somehow like, are they like neural nets? Is this like machine learning, or
It is.
how do they work? How does a neuron work?
Yes, a neuron is basically a wrapper for an AI engine. It's
Okay.
not a wrapper for one model or one specific model. Um, it's a wrapper for an AI engine which builds models.
Mhm.
So the engine watches the data. It chooses an
Okay.
algorithm, or
Yeah.
a set of
That's
algorithms,
how you can. Uh,
ML algorithms, AI algorithms. They watch the data, then they build this model, they back test, they then make predictions, broadcast that out. When the future happens, they now have more data to back test on and to make a better model. So they're constantly building models and replacing models and updating models so that they can make better predictions.
so can you tell me a little bit what does it mean building models? So let's say a neuron, okay, it has access to multiple models from what I understand.
Yep. Hmm. I think you got disconnected for just a second there. It's, yeah, it still says recording for me. Sure.
Uh, Yeah, so let's say you have a neuron. That neuron has access to different models. So, for example, it has access to models, it has access to some sort of text classification models, has access to LLMs. Um, you said it builds and trains its own model. How does that work? Does it provide the context of other neurons into that specific neuron, or like how does the training process operate?
Oh, excuse me. So the training process, the first thing it does is it subscribes to the data stream that it's trying to predict.
Okay.
So that's the very first thing. It's, if it doesn't have the history, it downloads the history, it gets the data. The second thing, and this is raw data, right? I mean, probably, right? It's just data that came from measurements of the real world of something. So it downloads the data. The second thing is it, kind of looks for which algorithm might be useful to predict this data. What are the constraints of my hardware? It starts to decide what kind of model do I need to make. And then it just starts looping. So it takes that data, takes the algorithm it chose, builds the model, and then it kind of validates it, sees how good it is, backtest. It gets a score, and it says, is this the best score I've had so far? Is this the best model I've ever seen?
Mhm.
And if the answer is no, well, let's say the answer is yes, it then saves that model and it has it. And it can use it. If anybody wants a prediction, it will, use that model immediately to provide a prediction. So it has it on hand. But even though it has a really good model,
Mm.
it then puts that aside and has it ready, but then it goes back to its training loop and does it again and again and again. And it's always looking for a better score, a better model than the one it has on hand.
Okay. I'm still a little confused. I'm sorry. I'm not that technical, so it does take some time for me to. I'm genuinely interested in seeing how you're modeling the brain. Right? It's not that I'm just trying to uh,
Sure. Yeah.
I'm genuinely interested in how these neurons work and how they train themselves and how they analyze themselves.
Yes.
Because sometimes you don't understand it, but it doesn't mean that it's not there. But it kind of feels like, for me at least, there is something missing in my understanding.
Sure.
So this, so let's say this neuron, it finds out which model to use. How does it do that? Like, what does this neuron? How does this neuron do that? Like, what? So it has a data stream. So let's say it's getting, okay, prices from, I don't know, forex USD CAD data feed. Okay, so it's going into it, and this price is continuously updating, and the feed is going. What is the neuron doing at that time?
Okay. Every time it gets a new data point, a new observation, uh, it adds that to its data set, and now it can train on more data. So it should be able to find a better model because now it has more data. So that's important to understand. Also, the other thing that happens as soon as it gets a new data point is it takes that data point and it hands it to. Did I lose you? I think you went dark here.
Uh, could be
Okay.
my camera. I'm
But
having
you
problems.
still see me?
Yeah, I can still see you.
Okay, no problem. I'll continue. So it takes that data, that piece of data, and it hands it to the model that it has on hand to predict. And so new observations coming in act as a trigger to broadcast a prediction of the next observation. So I think that's kind of important because that broadcast, that trigger, that can go out to other neurons that are predicting related items or related data streams. Um, it can inform them of the context in which the rest of the brain, the rest of the network, thinks that the thing they care about, whatever they're trying to predict, is in or will be in. It gets the future context of what it's trying to predict. So that's the way in which it leverages, and the way in which I think probably the main way in which it's brain inspired. Um, I'm not sure if that kind of helps your understanding, but there's one other thing. You might be trying to zoom in to find the link between the AI algorithms and what we're doing and the brain. But
Mm-hmm.
I think maybe the better thing to do is to zoom out and say, okay, well, how does the network as a whole mimic the brain instead of just one little neuron? The network as a whole operates on or uses a few of the principles that the brain operates on. So it's in that way that it's like brain inspired. So one of those principles is redundancy.
Hmm.
You know, the brain makes models of the world, and it makes models, a lot of them. It makes lots of models of the exact same thing. But every one of those models that it builds, this is the thousand brains theory from Jeff Hawkins. Every one of those models is slightly different. Just it's like from a different perspective, different point of view. Um, and so our network is doing that as well. So we have redundancy, but every neuron that's trying to predict a particular data stream, we have multiple neurons trying to predict that same data stream. But every single one of them is also trying to predict other data streams and has different data and listens to different contexts. So they build a unique model of that data stream that gives them predictions. And so their predictions are always a little bit different. And so what we have is the same thing that the brain does, unique redundancy, which is probably what gives us as humans the wisdom of the crowd phenomenon. And so we're trying to incorporate that into the network so that it has the wisdom of the crowd of these bots or these agents. And that's one of the ways in which the neuron network, the network itself, is kind of mimics some of the principles that are instantiated in the brain.
Ah, so basically, then now that I understand this a bit better, it's basically a decentralized version of like a machine learning model. So AI and ML is centralized, but this is decentralized, which gives it more, I guess, trust. So when you are doing these kind of forecasting, an organization, let's say, it adopts this technology and it can use it as part of a broader strategy to basically make decisions. But because it's continuously, I know. But does that mean that the Satori network you'll have to deploy like segregated parts of Satori networks? Let's say Microsoft wants to be your customer, okay, and so you will have to create like a separate network from Satori. Like, is that how it will work? Because
If there's companies or individuals that have private data, they want to keep private, yeah, we're going to need some kind of solution like that. If they have data that they don't care if the data is public, right? They don't care if it gets out. In that case, they can just put it onto the network and have the network. They still might want the predictions just to go to them. By default, the predictions just get broadcast to everybody. But if they want to just be able to get private predictions on public data, even if it's data they provide, then you can just use the regular network for that. Um, but yeah, if they want to keep their data private, then we have to segregate out and um, build kind of a smaller ideal solution for them. However, that part of the network that's just working for them, that's how it can still use the context of the broader network. So it can still have access to the world model and correlate the world with this company's data and use that to make better predictions. Um, so I guess that's kind of the value add that the Satori network itself, the open network, open distributed, free for everybody. That's kind of the value that it gives to these private solutions too.
right. So how heavy would it be? Like, let's say if you're running multiple predictions, how much resources does this require? Because from what I understand, you will need quite an extensive network to be able to perform. You will need lots of compute to be able to make these predictions. How efficient it is in predicting?
This this is an interesting question because it kind of just depends on the data. if you have lots of data and you want to use deep learning, and you want to do really fancy stuff, really heavy, um, then that can be a lot, right? It could be, but most data streams, maybe it's on an hourly cadence or a daily cadence. Um, it's not usually microsecond cadence. So most data streams have 10,000 or 100,000 observations, or maybe a million or something, but they're not like big, big data. And so you can use CPUs for that most of the time. So and even on the big data, you can still use CPU algorithms that run very fast. Um, so it's not as much as you might think.
Mm.
But the network right now has like 18,000 nodes, which like roughly equivalates to like 18,000 CPUs, because we do mostly CPU stuff right now.
Mm. So one could leverage such a network to do quite substantial analysis from what this sounds like,
Yeah.
because you can basically leverage 18,000 other machines in the network to analyze your data stream. And as long as that data stream is not private, then you have these kind of free data analytics and free machine learning. Well, not free, but decentralized, which means
Yeah.
it's a globally distributed machine learning network. So can you train models with this network? Can you like take and train like an AI model with this network based on a data feed, or like a just centralized AI model with a decentralized network?
Not really. I know a lot of, I mean, there's probably a lot of projects that are trying to do that, and
Mm.
we're not really one of them.
Mhm.
So since we focus on time series data, live data streams and raw data streams usually, um, what we really want to know is what the future is going to be. And so we don't want to use this network to train like some spatial structure, like a model of language or something. Like that's a static data set. So, so we don't really do that. Really, but the network itself, because all of the neurons are kind of broadcasting their predictions, which imply their model,
Right.
um, and they're all responding to each other's predictions, and they're all updating themselves based on the changes of other neurons. Um, they they do create this kind of loose, constantly updating, always up to date model, which is exactly what you need for being able to predict the future, because the future is always in flux, it's always changing. You need to be adaptable to it. You don't have time to like curate a bunch of data and train for 6 months and then you have a model that's out of date, right? The future's already happened.
Right. Right.
So you can't, centralizing this kind of thing is not really a great idea if you really want a world model like the large, to supply everything.
So
Um,
therefore, this world model also needs to leverage the future predictions in the current state. That's why, like for example, you have these large language models that are usually like 6 months, a year behind on the current knowledge, and this model is well. How do you can you train this model on the existing internet, or that's not no? But you're saying it's just for like time series data, so like stock prices or things like that. So
yeah, stock prices right now it's mostly numerical, right? Because we're early on. But there's algorithms that take in text and predict the future of text. So we have all kinds of stuff we can do. We're not limited to numerical data, but that's the easiest to model right now.
could you potentially have a decentralized LLM in
Yeah,
the future
yeah, totally.
because that's just prediction of text.
That's right. Now, what our model is for that layer, if you go to our website and you type in like a question, we have an LLM,
Uh-huh.
and it's sitting there, and what it does is it watches the network, and it will pull insights about the future out of the network so that it can talk to you about it. So I don't know if like a decentralized LLM trained on the network will ever practically happen, maybe. But the pattern we have instantiated right now and that we're going to run with for a while is a layer on top of this network that's kind of talking in the language of prediction, the raw language of the raw data streams that are down there. We have an LLM layer on top of that, which kind of watches it and then can translate what it's seeing into the future, into language about the future. So you can
So
ask
is
questions.
this it? Is this the layer?
Yeah, exactly. Now, since we have mostly crypto prices or the weather, it's probably best to ask a question like that. But yeah, perfect. Let's see what it says. This is brand new. We haven't even tested it out very much. But let's see. Yeah. So that's talking about kind of long term trends, it looks like, and long term predictions of maybe the maximum price of Bitcoin or something like that.
Mm.
Um, yeah.
Yeah, so it's interesting. So essentially, it doesn't have any specific. Uh,
Oh, it doesn't have a data stream on that one. But if you type in like any kind of like maybe a different crypto name, you'll get this pop up there that has that if you click on one of them, you'll see the actual predictions. So we try to make this LLM available, but oh, look at that, the prediction showing. We try to make the LLM available for like high level questions, and that'll continue to evolve. But also, if you just want to see the predictions on a particular data stream, you can do that. Maybe type in just Doge and see what pops up.
sure.
Did anything? Maybe, there. I don't know. Maybe you have to refresh the page.
You know,
And there's Euro, Coinbase.
then we can see the predictions of the model, and it's like,
Yes.
and it
Yeah, I
will
think,
predict it.
yeah, there's a UI issue there, I think, at the very end. But so you can see the history of the values and the history of the predictions. And you can see now this is the average, right? Because every data stream, of which this is just one, has multiple predictors on it. So this is the average of all their predictions over time.
Uh huh.
And yeah, you can kind of see if it correlates or is predictive. We don't really do a lot of analytics yet because we're so brand new to see actually how well the network is predicting. But we did want to put this graph up so that people could just kind of view it themselves while we get the other stuff ready.
Yeah, this is very interesting. I think a lot of people who are in the crypto space and who are actually trading would be really interested in building or investing in something like this. So
Yeah,
sort of like an expert advisor that predicts the future of crypto by analyzing the crypto or in this decentralized way.
yeah,
Yeah, this is super interesting. So I know a few people who are on crypto. I can share this project with them. I think it will be extremely interesting. For me, I think this is you know it's a very very interesting project. Now that you've explained it, it makes perfect sense to me. I it took me some time to get it, but now I get it.
yeah. Did you? I know we're not really building AI agents. I went to the Dawn of the Agents, whatever conference yesterday
Mm.
in Denver. Um, And even though we're not building them, did you have anything you wanted to talk about with actual like agents?
Yeah, yeah, yeah. I think we can talk about like the future of this technology and where it's headed. I know, like most of the podcast, it was just me interrogating you about how the thing works, and it was maybe it wasn't as what you expected, but I was genuinely interested. I thought
No,
this is time.
I'm happy you did. I'm happy. Um,
So
yeah,
yeah,
go ahead.
well, what was some of the interesting takes you got from the dawn of the Asians? Like what?
I didn't. Nothing really stuck out to me where I was like, "Oh, that's a brand new thought."
Right.
When I was listening, but so I kind of actually just went there mostly to network and meet
Mhm.
people and see who's in the space and stuff. Um, but I will say there's something about coding agents that I have not seen yet. That even though I'm not building this, I'm not going to build this. I think it will be built soon, but I would like to see it. Like I would like to see it happen. And so this maybe is kind of a more um, philosophical, but I think also practical take on what the coding agents need to, how they need to evolve. Because I started this Satori project basically by myself years ago on my own time, and we launched last year. So for years, I've been coding this project and others. Um, but for the last year, it's just been this one. So I code a lot. I'm a developer founder, right? And so I code a lot, and I still code a lot. And I always want to leverage the AI tools as much as I possibly can. And still find myself having a lot of difficulty really getting what I know could be every ounce of juice out of the coding abilities that we now have in LLMs.
Right.
So, and what I've noticed is that all these kind of coding agents that people have been trying to make take kind of a top down approach, and you get this nice demo where you can just say to the agent, hey, go make me a website that is a landing page or something like that,
Right.
and then it will just do it, and then everybody's like, wow, that's amazing. It's not practical to build that. I mean, it's not useful. I mean, I guess it's useful in that case, but what you really need is to instantiate the loop at the bottom of the development process. So right now, I and everybody goes out to the agent. We're coding along, we're doing our thing. We go to the agent, we ask for something, and it kind of writes it a little bit, and we modify it, and we test it,
Right.
and we run it in the code, and getting the AI agent to test it themselves is really what has to happen, right? And that includes other things like kind of having a supervisor, a context level kind of loop and ability. But the main thing is being able to allow the LLM to test by themselves. So that's Docker, or that's some kind of virtual environment, plus the LLM, plus prompts and RAG and whatever else needs to happen in order for it to generate test code first, according to your prompt. And then it frees up the human. It frees up the human to be a developer still, and to say, build me this feature or this function, or, something pretty small, but a little bit bigger than I don't know. It needs to be able to do that, and then the human can walk away. The human can say, "You have the entire code base. You can search through. You can learn about. You can explore in order to get this done. You have the TTD loop. You can write the tests. See if you wrote something that you think works, and just do it yourself, and then I'll be back to check up on you." And that's what we need, right? As far as coding bots goes, like Anthropic figured it out, and they said, "Oh, most of what we are used for is coders writing code. So why don't we build a language model just for that?" and it took a long time, in my opinion, for them to figure it out. But um, they did, and so everybody knows it's coding that this stuff is used the most for. And so I don't understand why somebody hasn't built uh, this loop in at the bottom of the developer stack, because once you do that, you free them up to then do that again on a different feature or on a different area of the code with a different AI, and eventually you it's a foundation upon which you can build higher level abstraction. So then you can have a supervisor bot or something like that that you can give instructions to, that kind of manages two agents that are now constantly looking over the code of that feature and the code of this feature, and they kind of overlap here. And the agents have a good model of how that works, and they're able to work back and forth and say, hey, I'm going to modify this and see, does it change anything in that piece of, in your tests, because it could have ancillary effects. And and this is, I feel like you need that coder developer TTD bot at the bottom of the stack in order to build out kind of a layer of LLMs on top of the code that you can then give what we want to give, which is the highest level um, demands. The CEO level saying, "Build me this," and then it kind of can flow down. But that's going to take time to mature. You have to build it from the bottom up. You can't build it from the top down. So anyway, I guess I don't know. I guess that was kind of my takeaway of what I talked to people about with the coding bots yesterday, and kind of the way the industry is right now in general.
Yeah, I think it's a very good thing. As a person who does work with these coding bots a lot, like Win, Serve, Cursor, whatever it is, it's all the biggest problem is the loop, where you have to sit there and you have to tell it to iterate over non-central answers. And as you mentioned, what would be great is, for example, you have a difficult problem, you have to integrate some complex technology into a complex code base. So you could run, let's say, 5 or 6 of these bots in parallel, and then
Yeah,
they can, whichever ones finish, they provide the results, then they compare, and then they pick the best result, and they give you that result based on the test driven, and it's tested, it's verified. So yeah, okay, they could have run for 5 6 hours, but in the end of those 5 6 hours, you got a working piece of code, and you didn't spend those 5 6 hours doing this yourself, which is the worst part about AI coding today is
that's right.
manual supervision, and it's a daunting, thankless process, which can be very frustrating.
You're absolutely right. I was thinking yesterday, there's this feature that I've been wanting to build, and it's not too hard, but I know exactly how to do it, and I could do it in a few hours. And I don't want to give it to anybody else because it would take them a long time to kind of get familiar, and so I thought, well, I wanted to build this feature for 3 days, but I've been busy. I've been doing other things and whatever. And I could have had a very bad LLM. If it was in the loop, if it had a loop, it could be Chat GPT 3.5, right? I mean, it could have been bad. Um, but it could have been churning on this for 3 days, and that would have been useful to me.
Yeah,
Right? So it would be done. So, and it kind of reminds me of the old word that we use for agents, right? Now, AI agent is an LLM that can do behaviors on your behalf.
uh-huh.
And but before, a year ago or a few years ago, agent was a machine learning algorithm, set of algorithms, something that moves through an environment, plays a game or something, right? And that's kind of the academic where that kind of came from, I guess. So, but that's the way all intelligence is. It's moving through an environment. It's navigating an environment. That's the point of intelligence, is if we can navigate our environment, then we can survive. We don't get eaten up. We can find food. So instead of, the top down approach is like, oh, build something, right? And that's kind of the idea, is build. But really, that's not the way we should view what the agent is doing. What the agent is actually doing is maneuvering through an environment. And the environment is all the possibilities that the code, all the possible states the code could be in, or whatever it's maneuvering through. So it's going to go down a path and modify the code, and it's going to go down a path and explore that path. And eventually it's going to say, that's not going to work. And this is what humans do. So eventually we say, oh, that's not the right way. And then we revert back, to a certain point in the path, and we go down a different path, right? And so we're walking through this, the state space of all possible code combinations, just like the AI would be. So I think that's a better framework to look at agents through, a better lens to look at them through, and understand what they're actually doing.
Yeah. I think this is the much needed project. I would work on this as well because this would make my life so much better and easier. Because you can have like a local llama running on your machine, churning away maybe five different agents working on the like five different problems. So five working on the same problem, but like trying to like work off each other and see how far they got and comparing results. And that would show collaboration. That would actually be. I don't know why Cursor and Windsurf that raised billions of dollars are not doing that.
Oh, I think they're getting close.
Yeah.
Actually, Cursor seems, I mean, I don't, use everything, but, Cursor, whatever its latest update or something is called, gosh, I forgot. But it allows the Cursor to use the terminal, and you need to be able to do that in order to execute code. And so I think they're getting close, and in six months,
Yeah.
maybe 12 or something, they're going to have something like this. And I'm very excited for that. I mean, somebody's going to do it.
Well, yeah, like Windsurf, they released MCP,
Oh, yeah.
so yeah, so it can connect to like your super base, for example, and it can
Cool.
like like it can connect to any of your existing kind of APIs and endpoints and interface with them, which makes development so much easier because then it will send the commands itself and it'll do everything itself.
Yeah. Cool.
Don't do it in your production database.
Yeah. Yeah. We need virtualization for that.
Yeah. Well, look, Jordan, it was extremely nice to have you on the show today. It was such a learning experience. You're a very smart person. I really appreciate you coming on. I'd love to see you um, come on again, maybe in half a year, to see how far this got. We'll
Sure.
we'll promote this as much as we can to see if we can get you some people who are interested. Are you selling any tokens, or how do you buy into this? Satori, and how do you get into Satori?
If you want to join our Discord, we have a very active community in our Discord, and a lot of it is grassroots. So people kind of like this idea, and I think they see, it seems like an obvious idea. So I think everybody kind of sees it's pretty cool, and that's kind of the feedback I get. So if you want to jump in there and talk, just reach out, and we'll figure stuff out. Now, it is traded. I mean, like if you're just asking about, well, how do I get some token? It's traded out there, and safe trade. It's on base as well, so it's out there. But I'd just like people to run neurons. Just run a node. You'll earn some tokens. And I think that's the coolest thing. So anyway,
Perfect. Well, this is Jordan Miller. Check out the Satori Network, uh, and feel free to support his project. Thank you so much for joining, Jordan. It was an amazing discussion. I really enjoyed it.
thank you for having me. We'll see you.